Today I'm going to do an orthographic projection question from the 2015 higher level junior cert paper. So this is question 1 from the paper. So it says a pictorial view of a concert stage is shown. Part A, draw the elevation in the direction of arrow A. Project a plan from the elevation. Project an in view in the direction of arrow B. And then part D is determine the true shape of surface S. Now, the elevation direction arrow A is pointing towards the right. So that means we need to draw the elevation on the right hand side of our sheet. The in view then, the arrow is pointing towards the left, so we're going to draw the in view on the left hand side of the elevation. Okay? And we're going to draw the plan view then directly below the elevation. So first thing we need to do is need to work out the length, the width, the height, and where we're going to position the XY line. So the length is radius 30, so it's 30 plus 30, which is 60, plus 120, which is 180, plus 30, which is 210, plus 30, which is 240. Okay, that's the total length. Now the width, I've put down 100 plus, because it's 50 plus 50, but we have this radius out here. We don't know how far out that is, so it's 100 millimeters plus. The height is 104 plus. Again, we have 80 plus 24, which is 100 up to here, and then we have an angle of 25 degrees then to the top. Okay, so because of that, I usually add on 20 millimeters down from my height for my XY line, but I've added on an extra bit here to take into accommodation the 25 degree angle of the height. So for my XY line, I'm going to come down 135 millimeters from the border on my page. And then I also have to consider drawing the true shape of surface S. So I'm going to leave room on the right hand side of my sheet to accommodate that as well. Okay, so the first thing I'm going to do is I'm going to set up my elevation box, my plan view box, and my in view box. Because I don't know the full height of the elevation or the full width and plan view, I can't complete my full box for my elevation, my plan view, or my in view. So now what I need to do is I need to start filling in the detail on my different views. Okay, so that's the front of my stage. So I marked in 30 for the radius 30, then 30, 60, 60, 30, and then 3 tens at the end. So that's the front of the stage. Now what I'm going to do is put the 2 pillars either side and then the main arena in the middle. So the 2 pillars are radius 20. you need to mark an angle of 25 degrees from your 80mm line there. And then it's the same on this side. Okay, so when you come out 60 from the center and you measure up 80 from the platform of the stage, then you go at an angle of 25 degrees. So then that'll cut off then the two pillars either side, and you can draw them in. Okay, so that's the elevation of the concert stage. I'm just going to highlight here surface S. Okay, so that's the elevation completed. Now I'm going to move on to the plan view. Now notice I only kept a distance of 5mm between my elevation and my plan view because the question is rather big and it won't fit on an A3 page unless you keep the minimum distance between your views. So when I'm drawing my plan view now, I'm going to have to project my lines down from my elevation, okay, and that'll give me the lengths in my elevation, then I'll have to mark the widths for my plan view. So you need to measure in 20mm, put a mark there, and then the circles in plan view then are radius 30, the outside ones. So mark in 30, and that's your position. So you can bring that across. Bring that across. Get your compass. Okay, now I need to draw in these two columns in plan view. So we said that the radius is 20, so get your compass. So the angle that's on the main stage then comes directly down from your elevation out to line up with the front of the columns. And then it goes at an angle then right out to the center of the front stage, which is in line with the main platform underneath. I have to do the 3-point arc at the front. So we know that one point of the arc is here, one point of the arc is there, and then the other point of the arc is in here somewhere. Okay, so it says that it's radius 90. So to get radius 90 on my compass, go from this point and describe an arc right in the center line. Then with your compass then draw in the arc and they should meet up. That gives us now the width of our plan view. And bring all my lines over to the edge of my plan view. Okay, so here's the edge of my plan view. So project everything over to that edge. So when you've that step completed then, the last thing that you need to do is you need to bring your lines from your elevation over to your in view. Okay, so now what we need to do is we need to draw what we can see from looking in the direction of arrow B. Okay, so from looking in at the direction of arrow B then, we're going to be able to see C. So in total we're going to have 1, 2, 3, 4, 5, 6, 8, 9, 10, 11. 11 surfaces that we're going to see. So I'm going to start with the curved surface in the front. So there's the line brought across for that. And I can put that in hidden detail. After that then, we have the steps. So again, follow your step line across, follow it up, and there's the point there, at the top of the step. The second step then, follow it over, follow it up, there it is there. third step then is further in and it's there. Okay, so now we need to just join them up. And there are the 3 steps. After that, then we have the curved surface. So there's the curved surface, there's where it ends. Bring that across, bring it up, and we can draw that surface in. Okay, so far we have 1, 2, 3, 4, 5, 6 surfaces. Okay, so now we're going to move on to doing the column and then the main arena. So the curved surface of the column then, what we have for that is we have a circle in plan view and we have a slanted line in our elevation. Now what that means is when you have a circle and a slanted line, the resulting shape in your third view is going to be an elliptical shape. Okay, so now we have to show that. So what I want you to do is in your plan view, divide up your circle using your 30 and your 60 degree set square. Now what we're going to do then is project these lines to our elevation, to the slanted line. We're going to label our points. Okay, so if we number this then like a clock, that's going to be 12. So afterwards then you have to bring your lines across to the edge of your plan view, bring them up at 45 degrees to your in view and then bring them across from your elevation. So my advice is take it line by line. So I'm going to start with 3, 9, so I have that brought up already, and bring across point 3 and bring across point 9. Follow 3 and 9 up, and that's point 3 and that's point 9. So now I'm going to do 8 and 10. So bring across 8, bring across 10, project it up with your 45 degree set square. There's point 8 and there's point 10. And what you need to do then is repeat the process then for the rest of your points. So the final thing then is the side of the stage. And then surface S. Now to get surface S, you have to bring this line down to your plan view, which gives you this important point there. Okay, project across that point. Bring that up. That there then gives you the width of S in your in view. So that's your plan, your elevation, and your in view of the concert stage completed. The last part is part D, and it says determine the true shape of surface S. So I've highlighted surface S in my elevation, in my plan view, and in my in view. So to show the true shape of that now, what we need to do is we need to get the true length of each line. Okay. Now, one thing that you need to remember with orthographic projection is all vertical heights will be true lengths. So that there is a true length, so is that line, and so is that line there. Okay. But what isn't a true length are these horizontal lines. The reason because this line is going at an angle in plan view. Okay. Now, if we want to draw the true shape of this, we have to make this line here parallel to the XY line. And then in elevation, we'll be able to see the true shape of surface S. So what I'm going to do is I'm going to do a rotation. I'm going to rotate this line so that it's parallel to the XY line, project it up to elevation, and then project across my points to show my true shape. So now I'm after rotating it, and now it's parallel to the XY line. So what I'm going to do now is I'm going to project up them 2 points to my elevation. And then I'm going to project across then my heights, because I said that they're going to remain true lengths. If I just project them across, and then I'll be able to join up my points to create my true shape. Okay, so I used a rotation in plan view so that I would see the edge of surface S parallel to the XY line, and then when I project that into elevation, it'll give me the true shape of surface S. Okay, so I hope that helps with understanding orthographic projection. And I hope that I made it clear on how to draw the elliptical shape in your in view when you're given a circle and a slanted line in your other two views. And I also hope that you learned a lot from the way that I found the true shape of surface S by rotating the line in plan view so that it was parallel to the XY line. Projecting it into elevation allowed me to get its true shape.